Hello, my name is Patrick Toby, and this is my presentation for my project Visualizing the Differences Between Forecast and Actual Temperatures. This is for my class Seminar in Advanced Software Development. A little bit about me. I am a graduating senior this semester, fall 2024, and I'm hoping to receive my BAS in Computing Technology and Software Development. Some of my hobbies include hiking and going to national parks. Here's some information about my project. My project focuses on creating visualizations that compare forecasted high and low temperatures to the actual high and low temperatures for that day. Some of the key features of my project include having 8 days of forecasted data, data recording for the area that I live in, which is Orlando, Florida, different options to visualize data, and this includes daily data visualizations that show you the differences between projected and actual highs and lows for a single day, and then also aggregate data for all the days. So my project is divided into three parts, which are the weather data collector, the backend data manager, and the visualization web portal. So the weather data collector collects forecasts and actual weather data each day. It then stores it into a database at the same time. It collects this data from two different APIs, which are the Open Weather Map API and then the Weather API. And these two weather APIs are professional grade to ensure that the data is accurate and reflects the actual and forecasted temperatures for Orlando, Florida. The next part of my project is the backend data manager. The backend data manager listens for requests from the front end. It then queries the database based on what the front end needs and then sends that information back to the front end so the front end can display it. The last part of my project is the visualization web portal, aka the front end. This part of the project is what actually showcases the data. So it shows the daily forecast and actual temperature comparison. It also shows how far the forecast deviates from the actual temperature on average. It also shows the largest deviation ever recorded for each forecast day. And then it also shows the bias for either higher or lower temperatures for each forecast day. Here's a screenshot of my database that has all of the data collected for my project. There are currently 28 days of complete data and an additional 8 days of incomplete data. The reason why we have incomplete data is the way that my data collector tracks forecasted temperatures. So, for example, on 11/28, that day hasn't happened yet, but we can start to forecast the 8 day and 7 day projections since we're less than 8 and 7 days away from that date. But however, we can't track the 4, 3, 2, and 1 forecast days because we're not that close to that date yet. And then additionally, we can't track the actual temperature for that date since that date hasn't happened. The languages I use for this project include TypeScript for the front end, JavaScript for the back end, and SQL for the database. The tools I use for this project include Node.js, ExpressJS, and Axios for the back end. I also use Axios, React, Recharts, RSBuild for the front end. And then for the database, I use SQL Server. For my IDE, I use Visual Studio Code. And then for my database manager, I use SQL Server Management Studio. And then for my version control, I use Git. My plan for this project has changed quite a bit during its implementation. I started with big aspirations and a large scope, which include everything that my project has now, in addition to having multiple cities to select from. I then decided that I needed to reduce the scope and get rid of the multiple cities and also the aggregate data functions. I then slowly added back the aggregate data visualizations as I completed more tasks and I felt comfortable that I could get those done as well. I then finished with a medium scope that accomplished more than the minimum version, but less than the initial scope. So I don't have multiple cities, unfortunately, but I do have all that aggregate visualizations. Although there's a lot of change in scope during my implementation, there were no changes in direction. The next three slides will showcase the graphs from the project website, and I will go over the results and findings from each graph. This graph is the daily graph, and it displays the actual and forecasted highs and lows for each forecasted day. So as you can see across the graph, there is a red line that is variable and a solid blue line that is variable. And those are the forecasted highs and lows as they change over the 8-day forecast period. So on the left-hand side, that's the 8-day forecast, and on the right side is the 1-day forecast. And then there's also a dotted line that's a little bit harder to see. You can see a little bit better on the left and right-hand side, but that is the actual high and the actual low for that day. So if you look at the chart, it started off on the 8-day forecast as being a little bit off the forecast that day. The low was quite a bit lower than, or the forecasted low was quite a bit lower than the actual low. But then for the next several days, the forecast is almost perfect. So the 7-day, 6-day, 5-day, 4-day, and even the 3-day forecast is pretty accurate. But then as you see, the 2-day forecast, the high ends up being over forecasted, being they forecasted as being a little bit hotter than it was. And then if you look clear to the 1-day forecast, it's quite a bit higher, the forecast is, than the actual temperature. And if you see at the bottom left-hand side, I have listed the actual high and the actual low. So the actual high for November 20th was 72.4 degrees, but the 1-day forecast that day was 83.41 degrees. So that was a 11-degree difference. So that's pretty substantial. So I think that's one of the best things about this graph is you can look at a particular day and see, was the temperature reflective of the forecast the day before or 7 days before? Because there's been times where I've done something outdoors and I expect a certain temperature and I get another temperature, and I've always wanted to look back to see, like, did I misread the forecast, or was the forecast that way off? So this is a good example of the forecast being considerably off. The next graph that we're going to look at is the aggregate deviation graph, and there's a lot to unpack with this graph. The first thing that we're going to look at is the bar charts. So similar to the last graph, on the x-axis we have the forecasted days. So on the left is the 8-day forecast, and on the right is the 1-day forecast and all the days in between. And then the bar charts show the average deviation between the expected high, the forecasted high and the actual high, and then the forecasted low and the actual low. So it doesn't matter if it's the forecasted high was 3 degrees warmer or 3 degrees cooler, it will add to this number. So it basically shows us how far off the temperature is on average. And for the highs, it pretty much stays around 3. It's about 3 degrees off on average each day. And that doesn't really change, which is really interesting. You would expect it to become more accurate as you get closer to the actual day, but it stays pretty flat for the highs. And then for the lows, it's pretty much the same story, other than on day 5 and day 4, those end up being a little bit more accurate for whatever reason. And those say a lower difference. They're a little bit more accurate. They're more about 2 degrees on average. So you can expect the high temperature to be different by 3 degrees on average, and you can expect the low temperature to be different by 2 degrees on average. In addition to the bar chart, there's the line charts, which shows the highest ever deviation statistic for a forecasted day. So this is like the biggest difference between the forecasted temperature and the actual temperature ever recorded on a particular day. So I just wanted to show how far off can a forecast be? Like what is the limits of it? So one of the data points here is actually that November 20th one that I showed in the last slide, and that's the 1-day forecast. That is 11 degrees off. And as you can see, the chart tends to have that 5th and 4th day dip, similarly to the lows, which is really interesting to me. It seems like those days have the highest likelihood of being accurate, which is surprising because you'd expect the 1 and 2-day forecast to be that way. But yeah, that's pretty much it for this graph. A lot to unpack, but really interesting information here. Last but not least is the aggregate bias graph. Similarly to the other graphs, the x-axis has the forecast days, starting from the 8-day forecast going to the 1-day forecast on the right. And what this graph is trying to show is if the forecast is wrong, is it more biased to be an overestimate or an underestimate? So an overestimate corresponds with a positive number here, and a underestimate corresponds with a negative number here. So one interesting thing you can see already is that the high temperatures are have a bias towards being uh, warmer than the actual temperatures. So each day the forecasted high tends to be higher than the actual high. And then the same thing happens for the forecasted lows. The forecasted lows tend to be cooler than the actual lows. And as the days get closer to the actual temp or the actual day, it tends to grow in bias. So on the 1-day forecast, there's a 3-degree bias for the high to be higher than the actual high. So to visualize this, if the actual temperature for the day would be 93 degrees, um, there would be a bias on the forecast of 3 degrees warmer on the 1-day forecast. So they would generally say like it would be 96 degrees on that day when it actually ends up being 93 degrees. And similarly, there's a 1-degree bias towards the low being lower on the 1-day forecast. So the 1-day forecast might say the low is going to be 67, but the actual forecast is 68. So there's not too much difference there. There's definitely a lot more of a bias towards the highs and the lows, but it's interesting how the bias tends to increase as you get closer to the actual day. During my project, I ran into several different technical challenges. These included difficulties with the automation of the data collector. I tried several different strategies to get the data collector to work automatically, but unfortunately, a lot of them didn't work in the beginning, and this led to a lot of inconsistent data that I had to delete. That happened around September, October time. But then I was able to land on having a scheduled task run on Windows, which ended up working as a solution. Another challenge I had was API downtime. One of the time of day that I had my data collector run was around 1 o'clock to make sure that I could get accurate data for the previous day while also having accurate forecast data for the next day. But it seemed like the APIs I was using had a downtime between 12 and 2, so I had to settle on having my data collector run every day at 2:30. And then lastly, there were some library documentation consistencies with some of those other uh, ways of getting the data collector to run automatically. During my project, I had several successes and disappointments. One of the first disappointments of my project was whenever I found out that there was no free weather APIs that gave me all the information I needed. But I was fortunately able to turn that into a success by finding 2 weather APIs that fit the needs of the project, and that were able to both have the forecast and the actual temperature. Another disappointment I had was the problems with the data collection. That was very frustrating, and it took me quite a bit of time to debug because uh, the data collector only ran once a day, so I had to wait a full 24 hours before making changes that I needed. And then lastly, one of the biggest successes was I learned a lot of meaningful weather forecast information for Orlando, Florida, so I can better be prepared for my outdoor activities. If I could redo my project, I would have started the project earlier. I wish I would have known that my computer wasn't strong enough to handle what I needed to do for my mentorship, or I would have chosen the project route instead initially. I wish I could have spent more time at the beginning designing the database because that led me to not be able to add the additional cities like I wanted to very easily because of the database structure that I went with. And then lastly, I wish I put more detail into a visualization plan. I had a good idea of what I wanted for my visualizations, but I never wrote down exactly. So whenever it came to actually making the visualizations, I had to really think about what I wanted to do, and I wish I had more of a plan from the get-go so I could tailor stuff more towards the visualizations. And that is the end of the presentation. I wanted to thank you for your time in watching this presentation. And if you had any questions, feel free to reach out to either my personal phone number or my school email that are listed on the slide. I'd be happy to answer any questions you have. And thank you again.